Hi guys, this says, show that the range for projectile fired from the ground at an angle theta with initial speed of v0 is the following. So this is known as the range formula in physics. And it's specific to a problem where a projectile is fired over level ground with an initial velocity v0 at some angle theta above the horizontal. That projectile is going to travel through the air and it's going to land back on the ground. And the range being found here is the horizontal range over the ground. So this is r. The nice thing about this formula is the only thing needed is the object's initial velocity and its angle with respect to the horizontal, and you get horizontal distance. So to derive this, the first thing that I'm going to do is I'm going to break up my velocity vector into horizontal Vx and vertical Vy initial components, and that gives me Vx is going to be V0 cosine of theta, Vy is going to be V0 sine of theta. From there I'll make a chart. So if I list out all of my variables here, so horizontally we have x and vertically we have y. In x there's no acceleration, so there's no change in velocity. So I have three variables here, vx, dx, and t. dx is also my range in this case, which is what I'm looking for. Vx I know to be v0 cosine of theta. And time I'm not sure about yet. In y, we have v final, we have v initial, we have a, d, and t. Now, I'm going to notice my picture and make some observations. So I know something specific about the vertical velocity at this point. When the projectile is halfway through its motion, so when it has traveled from its starting position to its maximum height, this is half of the time. I also know that the velocity there is equal to 0 in the y direction. So I'm going to use that fact to make life a little bit simpler. So I'm going to say that the final velocity of my object is 0. This occurs at the top. I'm describing half of the motion here. My initial velocity is v0 sine of theta. Acceleration is negative, and it has a value of g. Displacement I'm not worried about, but time would be very convenient to know. So I will use the first equation. So I will say Vf equals Vo plus At to get half of the time. So time, specifically half, is going to be Vf minus Vo over A. Plugging values in, we have 0 minus V0 sine of theta over minus G, giving me V0 sine theta over G. So V0 sine theta over G goes here. The total time is found by multiplying the half time by 2. So we get 2v0 sine theta over g. And since the horizontal range that I'm looking for is the entire horizontal range, I need to use the entire time. So I have 2v0 sine of theta over g here. And from there, using the equation that relates these three variables, I can find range. So I'm going to use the expression that range is equal to speed times time. So that is v0 cosine of theta times 2v0 sine of theta over g. And we get an expression here that is nice, but not exactly what we're looking for. We get 2v0 squared sine theta cos theta over g. But if we recall that 2 sine theta cosine theta is equal to sine 2 theta, we get the expression that we're looking for. So we want to recall that 2 sine theta cos theta is sine 2 theta. So we get v0 squared sine 2 theta over g. Hope that's helpful, guys. Thanks.